Hi everybody, Math 1010 online students, this is for you and anyone else who wants to be listening in. So when it comes to mixture problems, there are several different types of mixture problems. The one I'm going to be dealing with this time around is when you have a desired outcome in mind. In other words, in this particular problem, a candy store sells chocolate-covered peanuts for $7 per pound and chocolate-covered peanuts for $3 per pound, and the manager decides to make a bridge mix that combines the almonds with the peanuts. She wants the bridge mix to sell for $4 per pound. How many pounds of chocolate covered peanuts are required to create 20 pounds of the bridge mix? So they have an end quantity in mind. Okay, and then on this next problem down here, you work in a chemistry stockroom and the instructor asks you to prepare 6 liters of a 10% hydrochloric acid solution. So you know the end quantity. All right, and then they give you two individual starting dilutions to work with of an 8% and a 14% concentration. So I'm going to show you a way to do these kinds of problems. The book, if you look at books and all these other things, they'll show you how to do this using charts and whatnot, which are okay if you're a chart person. Not everyone's a chart person, so I'm going to show you maybe a different kind of an approach here. Okay, so I'm going to do this with two variables. Okay, so I'm going to for this candy problem, let's let x be the chocolate covered almonds, and then we'll let y be the peanuts. Okay, so what we're going to do here is create an equation, and I like to call it the amount equation. Okay, always start with the amount equation. That's actually going to be the key here. So x is the number of almonds in pounds, and then y is going to be the amount of peanuts in pounds. So again, these are amounts. That's the big thing here. So we don't know how many pounds of peanuts, we don't know how many pounds of almonds, but we do know that in the end it's going to equal 20 pounds, right? They tell us that right here. So that's going to be the first equation. X plus y equals 20. Now, watch very closely what I'm going to do here. Okay, that's going to be my first equation as it turns out. Now the second equation, anytime people do word problems, a lot of times they say the hardest part of the word problem is the setup. Okay, and so that's where I'm focusing here, is the setup of this problem. Okay, now this second equation, I'm going to have that one be the cost equation. For lack of a better term, that's how I'm going to label it. Okay, now watch how I start this off. I'm just going to rewrite my x plus my y equaling 20. Okay? But there's some things that I need to add to this. Okay? For our x, that was our almonds, right? How much are we selling our almonds for? We're selling them for $7 per pound. So, since x represents almonds, I'm also going to put 7 in there. Because what's happening is we're charging $7 per pound. Well, how many pounds are we talking about? That's where you have to multiply them together. So $7 per pound, so say you had 10 pounds of almonds, that'd be 7 times 10 would be 70. Obviously that's way too big because we have to have an end result of 20, but you get the idea. The cost per pound times the number of pounds is going to give you the total amount of cost for that item, in this case being the almonds. All right, now let's go over here and look at the peanuts. They're selling for $3 per pound. So we'll put a 3 right in front of the y, just like we did for the x. See how that works? And for the 20, we know we want to sell that mix for $4. So we're going to put a 4 in front of that 20. Okay? And there are my two equations right there. Boom. Second equation. Right? So there we've got my x plus y equals 20. And here we've got the 7x plus 3y equals 4 times 20. And I've got my two equations, so I can solve this thing. Should we do it? So we'll go x plus y equals 20. And then the other one is going to be 7x plus 3y equals 4 times 20. That's 80. Okay, I'm gonna go ahead and do that. And we're already set up to start doing this using probably the elimination method or the elimination addition method, same thing. If you want to use, well, if you're really into Kramer's rule, knock yourself out, you can do that. Graphing, well, I don't recommend graphing, so I'm not even going to go there. If you want substitution, it's actually set up kind of nice there because we have coefficients in front of our x and y of this first equation that can work. But I'm a huge fan of elimination, so I am going to use elimination. So I'm going to multiply that first equation through by a 3. So when you do that, you get negative 3x minus 3y equals a negative 60. And then I'm just going to rewrite this 7x plus 3y equals 80 down here. 7x plus 3y equals 80. See, we're set up for elimination right now. We'll go ahead and add them down. We've got 4x equals 20. So x is going to equal 5. So our x is going to be 5 pounds of almonds. 5 pounds of almonds. And then now it's going to be pretty easy, I think, to figure out how many pounds of peanuts we're talking about, because remember, we're talking about x plus y equals 20. Well, so now that we know what our x value is, that's 5. 5 plus y equals 20, so y is going to have to be 15. So we're looking at 15 pounds of peanuts. And that problem is done. Should we look at the similar situation for this next one? Okay, let's try it out. All right, so we're going to take a look at, we're working in a chemistry storeroom. So this time, let's go ahead and set it up where we've got our x value. Let's represent that by our 8% solution. And our y value, that'll be our 14% solution. So remember, we're going after our amount equation first. So remember how we did that? X plus y equals, what's our total amount here? 6 liters, right? So 6. And that is our first equation. Okay, now let's go after the, well, last time we called it our cost equation. This time we'll call it our concentration equation, for lack of a better term. You remember how we started it? Just boom, just rewrite that first equation. Again, that's going to be the key on these kinds of problems, I think, is just take that equation and just rewrite it down here and then supplement it with our percentages in this case. Okay, so we don't know how much of our 8%, so there's our 8%. So remember, let's turn that into a decimal, so 0.08x. For our y, that's going to be our 14%, right? So we'll go 0.14 there. And we also know what we want to end up with. We want a 10% solution, so we're going to go 0.1 and times that by the x. Right? And there's the second equation right there. Already set up for us. So now we've got our 2 equations that we can use and go ahead and solve this thing. So let's see how much time I have left. I only have 15 minutes to crank these problems out before my time runs out on this recording. So our first equation, we're looking at x plus y equals 6. Our second equation is going to be 0.08 x plus 0.14y, and that's going to equal, I'll go ahead and multiply that out, that's going to be 0.6, right? 0.1 times 6 is 0.6. So there's the two equations those are the two equations I'm going to use. Let's go ahead and not work with decimals. So I'm going to multiply that second equation through by 100. Hopefully you guys know how to do that. When you multiply through by 100, basically all you're doing is just moving the decimal place 2 locations to the right. So we're looking at 8x plus 14y, and that's going to equal not 6, but 60, right? Now again, I'm a huge fan of elimination, so I'm going to take that first equation and I'm going to multiply it through by a negative 8. And when you do that, you're going to end up with a negative 8x minus 8y, and that's going to equal a negative 48. So then the two equations we're going to use are going to be negative 8x minus 8y equals a negative 48. And that other equation again, I'm just going to take that 8x plus 14y equals 60. I'm going to use that. Again, we're using the elimination method. Okay, so we'll go ahead and add these guys together. Looks like I'm going to lose my x value here. Negative 8y plus 14y is going to be 6y equals 60 minus the 48. That's going to be 12. And when you divide by 6, we're going to find out that y equals 2. So our 8% solution is going to be 2 liters at 8%. And then to find out the other value, I'll use this x plus y equals 6. And then we know our y value, it's a 2, so we'll go x plus 2 equals 6. So when you subtract a 2 to both sides, we're going to get x equals 4. So our 14% solution, that's going to be 4 liters at 14%. Okay? And that is our answer right there. So hopefully this addresses mixture problems in a way that you don't have to deal with charts and tables and all that stuff, and hopefully this will be a helpful tool for you as you go ahead and solve your mixture problems. And again, if you're watching this and you're in my Math 1010 class, your first exam will likely have a mixture problem, and if you use these steps, I think it'll greatly help you as you work and study for your test and do your homework.